All right, we're gonna build functions today. So we're gonna add functions, subtract functions, multiply functions, and divide. It's actually pretty easy to do. If we want to add functions, it's exactly think you just add them together. Okay, you can subtract functions. We're just gonna subtract them. We can take the product of functions. We can also divide functions. Here's an example. If I wanted you to do two functions added together, f and g, all I do is that new function would become so f plus g of x. What is wrong with this thing? Sorry. Yeah. Thank you. Thank you. Thanks, Anna. Yeah, let's try this. Let's try this again. Here's the things that we can do to functions: add, subtract, multiply, and divide. So here's an example. If I want to find the two functions added together, all I do is f of g of x would equal x cubed plus the square root of x plus 1. That's it. All right. If I want to subtract them, f minus g of x would be x cubed minus the square root of x plus 1. This is tough, I know. And if I want to multiply them, that would equal x cubed times x plus 1. And if I wanted to divide them, then it'd be x cubed divided by x plus 1.
That's easy.
Yes, it is. All right. All right, composition of functions. When I do a composition of function, I'm going to read this f of g of x. I can use this notation or this notation. All right, so I can do either way. And we start basically to work our way out. So we're going to do, this means we're going to take x, we're sticking to the domain of g, and then we're going to stick it into the domain of f. So it looks like this. We're going to take x, stick it into g, and take that number and stick it into f, which we could also say it like this. We're just going to do this one operation and call it the composition of f and g. Right? So here's an example. If I want to find the composition of f of g of x, what I would do is I would take x, stick it into g, so I'd get this. And I would take this then and put that into the domain of the next function f. And so my answer would be 2 to the square root of x plus 1. Does that make sense?
Not really.
We did this last year.
Yep, you did. All right, so let's try this. We're going to take x now, and we're going to go the other way around. We're going to stick it into f first. So that would give us 2x, 2 to the x. We're going to take that 2 to the x, then and stick it into g. So it would go in right here. So then it would be the square root of that plus 1. So g of f of x equals this.
So you like skipped a step, right?
Let me try to do this slower, I guess. So if I want to find f of g of x, that's the same thing as g of x, and we're going to stick that into f, right? So let me do this. Let me do one thing at a time. G of x then would give you the square root of x plus 1, right? Now, would you agree? That needs to then go into f, so then that would give you, if I stuck that into f's domain, that would give you 2 to the x plus 1. So there's, I guess, if I'm not going to skip any steps, what it would look like. Thank you. And if I wanted to do the second one, same thing. I take x and stick it in, so I'm going to have g of, once I stick x into f, I get 2 to the x. Now I have to stick that into g, so that would give me square root of 2 to the x plus 1. So there's this one. There's part A. All right, hopefully that makes sense. Okay. Okay, so the other thing that we're going to do is go the other way around, which is going to be a little bit harder. We're going to decompose functions. So we're going to start with a composition of two functions. We're going to call that h of x. It's a composition of f and g. And I'm going to give you that composition, and I'm going to ask you to break it down into its original functions f and g. So my question is find f of x and find g of x such that if you did the composition g of x into f of x like this, you'd get this function. So let's go the other way around. Try that one and see if you can get it real quick. Yep. The two functions should be square root of x plus 5 and x squared. There's different ways to do it, but this is the most obvious way. And you can check this to make sure that this decomposition works. When I do this f of g of x. It should be f of g of x first, so g of x is x squared. So if I then take x squared and stick it into a function f, I should get the square root of x squared plus 5, which is my h of x. So I checked it to make sure that it works. This is the composition, and these are the two functions that would then make this composition if I put them together in this order. Okay. Now we're going to have a lot more of these in practice, so if this one, you couldn't follow this one, don't worry, we're going to go through a lot more of them, obviously in the homework. So, all right, the last thing is implicitly defined functions. Basically, what we have is we have some functions that aren't really functions. For example, an equation of a circle. We can all agree that equations for circles are useful. It'd be nice to study them, it'd be nice to use them, but they're not really functions. They don't pass the vertical line test. So we're gonna call these relations. And we're going to find out ways to implicitly define them such that we have y equals a positive and y equals a negative. These are two then separate functions. That when that way we can make them functions. So in this circle we have the top part, which is this part right here, and we have the bottom part. Together they're not a function. They don't pass the vertical line test, but individually each one of these are functions, right? And we're going to call these implicitly defined functions. It's not hard to find these. Well, I should say this one's not hard to find with a circle, because what you do is you take the x squared plus y squared equals 4 equation, and you just solve for y. So you subtract x squared from both sides, you square root both sides, and make sure when you square root you do plus or minus, and that's how you get these. Okay, that's easy. Now there's a little bit more difficult way, or one to do, and that's this here, because it's an ellipse, and we're going to have to complete the square on this. So why don't you guys try this one? Try to solve this for y. I think you've completed the square before, but this is going to be the hard part. This quantity right here, 4y squared minus 24y, you're going to have to complete the square on that to turn that into a perfect square trinomial. And I know it's been a while since you've completed the square. You did it in Algebra 2. I think you might even do it in Algebra 1. I'm pretty sure. But anyways, let me remind you, when you complete the square, when I taught completing the square to my algebra students, I gave them steps. And the steps were, number one, make sure a is 0, basically. So factor to get a 0. I'm sorry, factor to get a equal to 1. A is the term in front of the first coefficient on a quadratic, correct? Remember a squared plus b squared, I'm sorry, ax squared plus bx plus c is standard form for a quadratic, right? A is right here. So it's in front of the, so here's A. I need to get that equal to 1 before I complete the square on this quadratic. Step 2 is to add b over 2 squared to both sides. That actually completes the square. Step 3 would be to factor the perfect square trinomial. These are the steps I gave my algebra students for completing the square as a reminder. I know you've already learned this, so if you have your teacher taught a different way, or you have a different way to complete the square, feel free, whatever works for you. This is the way I do it. It's easy, and it works. So go ahead and try to solve this. You're going to have to complete the square on this by conveniently factoring it, and then adding something to both sides to complete the square, factoring it to get the y's together, basically, and then solve for y. All right, go ahead and try it. If you can't get it, don't feel bad. We'll go over it together, and we'll practice it in the homework some more. So we are going to focus on this part right here, and we're going to pull out a 4 so that we have this quantity left over, which is our quadratic that we're completing the square on. Now what we're doing is following these steps. We need to factor to get a equal to 1. We've done that. A is now 1 right here. So we're done with step 1. And next we're going to complete the square on this polynomial, this quadratic, so that we can turn it into a perfect square trinomial and get just 1y. So we're done with step 1. Next we're going to add b over 2 squared to both sides. So I need to look at what b over 2 squared would be. B is -6 here. So b over 2 would be -3. And we need that squared. So -3 squared is 9. I'm going to leave it as -3 squared, though, like that. I always leave it like that. And the reason why is because when you would have factored this perfect square trinomial, you just put y here and you put this here. So I'll show you that in a second. But now I need to think about, I just added -3 squared inside of this quantity. So I just added 9 inside of this quantity, but that 9 is going to get multiplied by 4 eventually, would you agree? Because that 4 gets distributed. So what's 9 times 4? 36. So what do I need to add to the right side to keep the equation balanced? I got to add 36 to the right side in order to keep this equation balanced. I just added 9 times 4 to the left side. So I've got to add that to the right side. Now this factors. This is a perfect square trinomial. Every time you complete the square and add b over 2 squared, you get, it's simple. This turns into y minus 3 squared. Every time, I just put this here and this here. That's why I leave it like that. You know, sometimes if you, the problem is if you put this to a 9, which is what it really is, a lot of times people will make a plus out of this and say, okay, well, the square root goes here, this, in a perfect square trinomial, the square root goes here, which is true. But this is actually a minus sign. It could, you know, y minus 3 squared will give you this, which is what you want. So that's why I just leave it as negative 3 squared right here. And I just put that here and in this part here. All right. Now I'm getting there. I've completed the square. So I've followed these steps to complete the square. That's good. And now I just have 1y and 1x, which is great. Since I have 1y and 1x, now I can solve for that 1y to get an implicitly defined function. So you guys can handle that part. Go ahead and try it. But let me tell you real quick what you guys didn't know to remind you. Is you guys put this in standard form for a conic section, which I think is an ellipse. You guys divided both sides by 36. You guys remember doing this when you did it? This turned into 1. And then that canceled to 4, and this canceled to 9. And then you had it in standard form for an ellipse. That's what you did last year. You know, it's been a while. But now I want you to do something slightly different, which is graph it in your calculator. And the way you graph it is solve for y. Solve for y, you're going to get plus or minus at some point when you take the square root of both sides. But go ahead and try to solve for y. I, from this point, would subtract 9x on both sides, 9x squared. Right? That gets rid of that. And now I would divide both sides by 4. And this turns into 36 divided by 4 is 9, so I guess I'll simplify that to 9. Then I would square root both sides. Don't forget to do plus or minus now. So that's plus or minus the square root of 9 minus 9/4 x squared. And then add 3 to both sides. So y equals 3 plus or minus the square root of 9 minus 9/4 x squared. Now if you graph this in your calculator, the positive part should give you the upper part, and the bottom should give you the lower part. And my graph shows them not touching, but I think that's just a graph for error. They should, all those points are there. So let's go ahead and graph that. I know it looks ugly. That's okay. Don't just follow your PEMDAS in reverse order. Follow your operation rules for algebra. Don't worry about what it looks like. We're gonna be doing complicated functions all year long, and you get more comfortable with it. But let's go ahead and graph this one real quick. Okay, so we type both these equations in, the positive one into y1 and the negative one into y2, and graph it. It looks like a circle, but that's just because of our window is not really truly rectangular. You can see these coordinates are close. That y coordinates closer together than the x's on our window. So that's why it's distorted a little bit. And that's just a graph for error right there. Those points should really connect. All those points are defined. So that's what it should look like. I know we're going to need to practice this a little bit more, which is fine. Homework is what? All right, so here's the homework. Go ahead and give it a try. Hopefully this helps.